Welcome to Homework Lib.
Here we're given that the range of a particle thrown as a projectile is going to be equal to b squared times sine of 2 times alpha in this case, divided by g. And what we want to know is find, using calculus, what is the alpha for maximum range. So what this means is that if we take the derivative of r with respect to alpha, what we want to get is that this needs to be equal to 0, right? Because we're at an extreme. This is going to be equal to b squared over g, the derivative of sine of 2 theta, of 2 alpha, with respect to alpha, which is going to be b squared over g times 2 times cosine of 2 alpha. And this needs to be equal to 0. So now, this part can only be 0 if cosine of 2 alpha is equal to 0. Thus, if we remember, so what this means is that 2 alpha needs to be equal to n times pi 1 minus 1 half. What this guarantees is that for all of the values of n being equal to 1, 2, 3, and so on, in the integers, we're going to be able to satisfy this condition. But for this case, we don't know which ones are going to be maximums and which ones are going to be minimums. So for us, what this guarantees is that alpha is going to be n pi divided by 2 multiplied by 1 minus 1 half. And the only thing that we have so far is that this may be a maximum or a minimum. So in order to guarantee that we have a maximum, we need to look at the second derivative and recall that the second derivative of a function evaluated at a point in which we found it was equal to a minimum, if that was equal to a maximum or a minimum, if the second derivative is lower than 0, then that point is maximum. And if the second derivative at such point is larger than 0, that means the point is minimum. In addition to that, we can actually simplify our result a little bit by noticing that we are within the first quadrant. So the angle alpha is the one that we're going to find here. So the values for alpha that we're going to consider are going to be from 0 to pi over 2, or from 0 to 90 degrees. In this case, the values of alpha that we have, let's repeat the formula, n pi over 2 times 1 minus 1 half. What we're going to do is find the values for alpha 1, which is pi over 2 times 1 minus 1 half. This is going to be equal pi over 2 times 1 half, pi over 4. And let's calculate as well alpha 2, which is going to be equal to pi over 2 direct. You can verify both of these results. So those are the ones that are within the range that we have. Remember that pi over 4 is the same as 45 degrees. So now, employing the criterion of the second derivative, what we're going to do is take the second derivative of this function. So the second derivative of r with respect to alpha is going to be, we're going to take the value over here for cosine of 2 alpha. We are going to take out all of the constants over here. So this is going to be equal to the derivative with respect to alpha of the derivative of r with respect to alpha. This is going to be the derivative with respect to alpha, partial alpha, of 2 times b squared over g times cosine of 2 alpha. Let me put it in the square brackets and verify that the result was correct. Yes, 2b squared over g cosine of 2 alpha. So the second derivative with respect to alpha is going to become minus 4 times b squared over g sine of 2 alpha. Now for the two values that we collected, alpha 1 and alpha 2, we're going to evaluate which value is it. So for alpha 1, this becomes minus 4b squared over g sine of 2 times alpha, so 2 times pi over 4. This is minus 4b squared over g sine of pi over 2. And as you notice, this is going to be lower than 0 directly because sine of pi over 2 is going to be positive. So this corresponds to a maximum. So with this, we have concluded that the angle for maximum range is going to be equal to pi over 4 or 45 degrees, which is what intuition tells you with this type of problems, right? So you can verify that the second case, what you're going to see is that the value is going to be positive, thus is going to be a minimum. So we can actually make it like in purple over here, like in a very small space, just to verify that alpha 2 equal to pi over 2 is going to be a minimum. What we're going to find is that the second derivative of r with respect to alpha is going to be evaluated at this point at pi over 2. It's going to be minus 4b squared over g sine of pi. So this is going to be equal to 0. Thus, that is going to be an inconclusive result. But regardless, the maximum value is already given here. The other one is going to be a minimum because corresponds to just going up and down again. So you don't have any range. The range is equal to 0. So that is already a minimum. So with that, it would be all. Thank you very much and have a good one.